Welcome to Brain Vision.
16.54, so we have two sinusoidal waves that have the same amplitude and wavelength traveling through each other along a string. And so we're shown the resultant wave here at 2 points in time. And point A here we're told is an antinode. And we're also told that the time difference between these two waves, between the two configurations of the string shown, is 6 milliseconds for A to go from its maximum positive to its maximum negative amplitude. These are separated by 10 centimeters. Then the overall height of this is 1.8 centimeters. And now we want to let the equation for one of the two waves be given here. And so for the other wave in its equation, we want to find y sub m, k, omega, and the sign that goes in front of omega. Now we could be taking this too literally. Y sub m, k, and omega would be just the same between the two, and so you just say those are the answers, but they want us to find actual numbers for these things. So first of all, because we have a standing wave here, this sort of implied that this is what the situation is. So we expect one of our waves to look like this, and so the other wave is going to look the same, except with the opposite sign in front of the omega. So all of the parameters have the same values, and we've actually already answered D. This will have a negative sign because it has to travel in the opposite direction. So now just going through this, y sub m is going to be this distance here, which we're told twice the distance we want is 1.8 centimeters. So this has to be 0.9 centimeters or 9 millimeters. So the wave number is 2 pi over the wavelength. And we can just look at this and see that the wavelength is 10, 20, 30, 40 centimeters. So wavelength is 40 centimeters. And so the wave number is going to be 16 radians per meter. So now the time for half of a full period, so a full period would be starting up here and then going down and coming back. So that means that a full period is going to be twice this time difference we're told, so 12 milliseconds. So omega is 2 pi divided by the period. Or, in this case, this evaluates now to 520 radians per second. And so since we know it has to be traveling in the opposite direction for it to be producing a standing wave, the sign of omega is negative because it looks like this.